Hello, my dear students. Class 12th, topic name haloalkane and types. First of all, we need to understand what are haloalkanes. Haloalkanes are also known as alkyl halides. So the name is suggesting haloalkane. Halo represents halogen. Halogens we know fluorine, chlorine, bromine, and iodine. Alkane is very well known to us. Those hydrocarbon chains in which carbons have single bond between them and rest valencies of them are satisfied by hydrogen, like this. So when any one hydrogen is getting substituted from halogen, like in this case, this was the alkane of 3 carbon, and you can watch the hydrogen of this carbon is substituted from fluorine. So this organic compound which we got, it is haloalkane, which also known as alkyl halide. So in this fashion, we can have different type of haloalkanes depending on the alkane chain length as well as type of halogen is used. And the exact definition of haloalkane, if I talk about, it is monohalogen derivative of alkane. Monohalogen means only one halogen you have to add there and one hydrogen will be replaced by it. So if I talk about types of it, types of haloalkane, there are 3 types: 1 degree, 2 degree and 3 degree. 1 degree is also known as primary haloalkane. 2 degree we call secondary haloalkane, and 3 degree we call tertiary haloalkane. Now what is the difference? This is 1 degree haloalkane. X is representing halogen connected to a carbon which is further directly connected to single carbon. Such type of haloalkanes are considered as 1 degree haloalkane. Now if 1 degree is understood, secondary is very easy. This X is connected to the carbon which is further directly connected to 2 carbons. So this is 2 degree haloalkane. Similarly, 3 degree. X is connected to the carbon which is further connected to 3 carbons directly is 3 degree haloalkane. For example, if I solve this case, so this is cycloalkane part to which chlorine is connected. Here we have two hydrogens. And here we have only one hydrogen. So this carbon which is directly connected with chlorine is further directly connected to 2 carbons. So if I find the degree of it, so its degree will be 2 degree. It's 2 degree haloalkane. Similarly, if I have this case, so check this. This fluorine is connected to this carbon which is further connected to 1, 2, 3. 3 carbons. So the degree of this haloalkane will be 3 degree. If I talk about this one, so easily we can find the fluorine is connected to this carbon which is further connected to the single carbon. It is 1 degree haloalkane. So in this fashion we can find out degrees of haloalkane. One more type of haloalkane is there which is known as methyl halide, in which only one carbon is available, like this. Or at the place of chlorine, a journal X we can use for halogen. So this is methyl halide. So total 4 type of haloalkanes we have. Methyl halide is there, 1 degree haloalkane, 2 degree haloalkane, and 3 degree haloalkane. Some more type of halides are available. Allylic halide. What is the condition of allylic halide? This is the condition. X should be connected to the carbon whose hybridization is sp3, and that sp3 hybridized carbon should be directly connected with double bonded carbons, alkene carbons. So now, how to find hybridization of carbon? Look, it's very simple technique. We know carbon can make 4 bonds. So if all 4 bonds are single, so the hybridization will be sp3. If out of 4, 2 bonds are single, 1 is double, then hybridization will be sp2. If 2 are double bond, the hybridization will be sp. If 1 is triple, 1 is single, again the hybridization will be sp. So in this fashion, by counting lines around carbon, you can check its hybridization. So this is the condition of allylic halide. For example, if I am writing this. So this is X, chlorine is working as X here, connected to this carbon. Now, what is the hybridization of this carbon? It have all the 4 lines single, so hybridization is sp3. Now check this side. It is further connected to doubly bonded carbons. So we have allylic condition over here. So this is allylic halide. This is allylic halide. Similarly, suppose if we have this type of alkyl halide. So now let's check what condition it is adopting, whether it is allylic halide or not. This is X connected to this carbon. Now what is the hybridization of this carbon? If I write 2 hydrogens like this, so I can easily find the hybridization of this. All the 4 lines are single, means the hybridization is sp3. Now this sp3 is further connected to these 2 carbons, which are alkene carbons. That's it. This is the condition of allylic halide. Means both are allylic halides. In this fashion, you can find out whether they are allylic halides or not. Now, allylic halides are also of 3 type: 1 degree, 2 degree, 3 degree. The carbon which have sp3 hybridization, if further connected with single carbon like this, so the hybridization is, the degree is 1 degree. This is 1 degree allylic halide. Now what will be 2 degree allylic halide? This condition. The carbon, sp3 carbon, is connected to this carbon and this carbon, 2 carbons directly. So this type of allylic halide will considered as 2 degree allylic halide. And then what will be 3 degree? This is sp3 hybridized carbon connected with double bonded carbon, so it is allylic halide, but it is also connected with 2 more carbons directly. So the degree of this allylic halide case is 3 degree. So this all we have allylic halide. Next category is benzylic halides. Now what is the condition? As the name is suggesting, benzylic means benzene ring is involved over here. We know this is the shape of benzene ring. You can also draw it like this, or you can represent it like this. So This is the condition of benzylic halide. X is connected to the carbon whose hybridization will be sp3, and we can easily calculate hybridization by just checking the lines around the carbon. So this is a sp3 hybridized carbon if it is making all the 4 lines single, which is further directly connected to a benzene ring. So such type of halides are benzylic halides. Now they are also of 3 type: 1 degree, 2 degree, 3 degree. How? If we talk about this type of benzylic halides, so you can check X is connected to the carbon, sp3 carbon, which is further connected to a single carbon. So this is 1 degree benzylic halide. Let's make it 2 degree now. X is connected to a sp3 hybridized carbon, which is further connected to 2 carbons. So this is 2 degree benzylic halide condition. And what will be 3 degree? This one. X is connected to the carbon which is further connected to 3 carbons. You can check the hybridization of this carbon is sp3 connected to a benzene ring with 2 more carbons with it. So the degree of benzylic halide is 3 degree. Next category is vinylic halide. Very easy. This one. X is connected to sp2 hybridized carbon, means alkene carbon. This is vinylic halide condition. It can also be of 1 degree and 2 degree category. Like this one is 1 degree. 1 degree vinylic halide. If I draw it like this, now this is, you can check, this carbon is further connected to this carbon and directly connected to this carbon. So 2 carbons, it is getting directly connected. So the degree is 2 degree vinylic halide. So 1 degree and 2 degree vinylic halides are possible. If I talk about 3 degree vinylic halide, they are not possible, because to make it, I have to do something like this. So you can check the carbon is making 1, 2, 3, 4, 5 bonds, which is not possible for a carbon. So vinylic halides are of 2 types: 1 degree vinylic halides and 2 degree vinylic halides. So I hope you got haloalkane and its type, and other halides like vinylic halides, benzylic halides, and allylic halides. So thank you very much. That is all for today. Thank you everyone.